Nu, pašnekėk, ką nori.
Vytai, ateik čia. Ateik. Nu, girdi ką nors, ar ne?
Yra dėlėjus, yra.
Tu, bet tai nieko.
Viskas okei.
Jaudiniesi?
Baškėjau.
Šalta laukia.
Ne, aš su mašina, kaip aš atgal važiuoju.
Tai su mašina?
Majoj. Vieną kartą pamačiau, kada buvo labai jaunas vyras sugalvojo, tiesiog viskas labai...
Sunku buvo vairuoti ar kas?
Ne, kalbėti iš žinai galvoja, čia kur iki 40 galvoja, čia gerai 90 galvoja. Ačiū Dievui, kad mintų nebuvo, bet paskui sakiau nevės.
Tik labai pagiriotas. Nu, praktiškai ir, žinai, 2 valandas pamiegi po visos nakties. Taip atvažiuoju dalį, o kaip gali ugnį pulti. Ne tai, kad durnai vairuoji, bet sustabdysi tai.
So guys, we will start shortly in 10-15 minutes. Let's wait for maybe some more people joining to our meetup. Let's have some snacks, drinks, maybe someone. Okay. So thank you for coming over for Python meetup, and it's a pleasure to break a pause between my Python meetups and to host a Python community here in Rocket office. Thanks for those who came. Thank you for speakers. And today we will have two topics. So first topic will be about test automation infrastructure for mainframe, presented by Mateusz and Vladimir. And second topic will be intro to wave function collapse by Petras Danavičius. So we will have a pause between topics, and let's start with the first one. So Mateusz, Vladimir.
Hello everyone, my name is Vladimir. I'm working in Rocket Software 6 months. Before Mateusz will start to speak about mainframes and Omegamon, I would like to do very short introduction about who is the Rocketeer, do the Rocket Software build the rockets, and who is the Rocketeer in the world. So, who is the Rocketeer? Is the Rocketeer hero? Yes, everyone who is working here is hero. You can be hero too. Do we control spaceships and rockets? No. Do the Rocket Software build the rockets like Elon? No. We built only one rocket. It's here. It's a Lego rocket. Okay, so who are we? We are Rocketeers in digital world. We're building digital rockets for helping people to understand and discover binary universe. So that was a short introduction. Mateusz.
Hello everyone, my name is Mateusz. I work in Omegamon for storage team in quality assurance as that, and I'll be doing a short introduction to mainframe and Omegamon products. So let's begin. So here's an example of one of our test scripts, one of many. Here we have a test for creating new user action in new comment tab. So we initiate the script, we create this action, apply it, edit it, delete it, and then assert every of these actions. So it either passes or fails. But before we move to more Python stuff and why we use it in Rocket Software, how it's beneficial for us to do these test cases, we need to know about the system that we will be testing on. So what is mainframe? So basically, an example, we have a bank or a credit card company that needs to process millions or even billions transactions a day, an hour, or even a second. Or we have a government that has millions of citizens. They need to process millions of records. Or we have an insurance company that needs to process millions of invoices. So what that tells us that mainframes are designed to do and complete vast amount of small tasks extremely quickly, and not to be confused with a supercomputer, which is good at completing one huge task like weather forecasting, and it's good at numbers crunching. Mainframe is basically good at completing a lot of small tasks extremely quickly, and in this case, processing business transactions. So as mentioned before, mainframes are used by top banks, retailers, insurance companies worldwide, and every one of you who has a debit or credit card and interacts with ATM daily, maybe without you knowing it, also use mainframe. Some facts about mainframe: so can run up to 90 billion transactions a day, handles most of the credit card transactions, hosts more transactions daily than Google, and can survive a huge earthquake. Also, we need to store somehow data on mainframe, so a common data structure on mainframe to store data is a dataset, and a dataset is just a file that contains one or more records. At a very basic level, there are two types of datasets. So one is physical sequential, which is compared to a flat file in Windows. You open it, you see some data, and basically you can store here medical records, insurance invoices, some macros, or some GCL code, which is job control language for mainframe, like one here. Another type is partition dataset,
which is like a folder on Windows. You open it, you see some files. In this case, it's called a member in mainframe world, so it can be one or thousands of these member files. And you open that file and you see some data as well, some code like here. Okay, so now we know about mainframe, we are experts in it. So now we need to know about the product that we will be testing. So what is a Megamon? Here we have a mainframe machine. It has all of these subsystems, and for each of these subsystems we have a Megamon product. And here in Rocket Vilnius we maintain and develop these Megamon products that basically a customer that is using mainframe environment can monitor their mainframe environment subsystems and see overall health of their systems. And yeah, basically they are using these Megamon products to prevent big issues on mainframe, because believe me, we don't want any major issues on mainframe, because if you have some, and if you are like a bank, you will have a financial and reputational damage. One of the products example is a Megamon for Kix on ZOS. So Kix is Customer Information Control System, ZOS is Mainframe Operating System, and Z stands for Zero Downtime, which tells that mainframes are high availability. And here we have some Kix region name, and customer can see how it's behaving, is it good or bad, is there potential issues that might be. Another example is a Megamon for storage. So storage tells us that we will see some volume, device addresses, how much free space do we have. So basically a lot of metrics for each system. Also we have the Wallet Enterprise Portal, short for TEP. So what you saw in those previous two screens, which are represented in the mainframe terminal and this old school view in black screen, here you can fetch and collect the same data in more like user-friendly way. So for a customer who is not familiar with mainframe environment, can maybe with a few mouse clicks see this data and don't need to know how to enter some commands into terminal and just use them. One more product is Zoe, so it's a framework on ZOS, basically very familiar user interface to Mac or Windows. So you can just right click, select some of the applications installed and use it out of the box. And for example, we select one of those applications, which is RDM for storage. So again, here you see a lot of data sets. Here you can filter them, rename them, delete them, alter them, basically do a lot of actions. Also with just a few mouse clicks, and you don't need to know any GCL or anything like that. So also beneficial for users who are not familiar with mainframe. Or if you are familiar with mainframe, you can access a mainframe to a terminal through Zoe. So here you would just type in log on, enter your username, password, and then enter the desired mainframe panel. So in conclusion, we have hundreds of different UIs, tons of data and metrics, and very critical systems. And before we hand any of these applications and tools to a customer, we need to ensure they are bug-free. So how we use Python and how this test automation framework is beneficial to us, I'll let Vladimir to demonstrate.
Okay. Hi one more time. So let's speak about that. We have test cycles in Rocket software. Jenkins helps us to run Python test scripts. What is a Jenkins? Jenkins is an open source automated server. It helps to automate part of software development, related to building, testing, and deploying. So Python test scripts working with user interface, E3270 tab, Zoe for interaction with mainframe. Each test has a result. All results are updating with gzip here and Jenkins. So TAF is a part of Rocket software company. each project should have quality automation coverage, be built and tested with a CI/CD pipeline, report to QA dashboard, report to the firm. Here's an example. R Squad. It's a Rocket software quality dashboard. You can see here the results. This one is a Zephyr for Jira. It's the same. You can see status of each test. So, TAF is built using Python around PyTest framework. TAF contains tooling for controlling Windows box, config environment manipulation, 30-70 terminal emulation, work with GCLJS, the FTP, DB2 methods, etc. So, job control language is a set of code to tell operation system about work you want to perform it. You can see here as an example. CRS use job system entry, job entry subsystem to receive jobs into operation system. On the EOS, we are reading and writing datasets through FTP, submitting GCL and watching logs. GCLJS and the FTP are using for remote measurement of jobs on the data frame. You can see example. So this is animation. It shows how it's work. The Rocketeers writing Python test scripts and running on mainframes, and each test has a result: pass, failed, or skipped. We have three interfaces. The first one is a 3270 emulator. The Rocket software has its own Rocket terminal emulator called Blue Zone. Rocketeers use own Python library. It's called Beacon for working with E3270 emulator. This demo shows how does it work. The test script working with the user interface E3270. We're just connecting and checking some values in the tables. And after that, we are updating status of each test in Zephyr. The second is Zoe. Zoe is application framework, contains a web user interface that has one feature. It can be automated with Selenium. The Rocketeers are using standard library Selenium for working with Zoe. This demo shows how does it work. We are running test script for connection to Zoe. We are using Chrome driver to that. We are using XPath for objects where we want to go, what we want to collect and check. You can see here. So we can put some data sets, get it and check it. So the third interface, it's a tab, Tivoli Enterprise Portal. Tab can run as a browser applet or as Java application. We are using Out Agent, which helps to mapping objects for tests. Out Agent is a part of Joomla functional testing tool. Rocketeers use own Python library pjoomla for working with tab via Out Agent. In this demo, you can see we did object mapping to get final destination to the table to check values in the table. So we are doing object mapping step by step. So you can see here the final destination was this table and values. So test automation framework has a lot of benefits. It increases efficiency, speed and test accuracy, reduce human overload. Tests can be run on different platforms, hardware or operation system configuration, etc. Thank you. Do you have questions, maybe?
I do. So, presentation. I liked it a lot. So you were talking about like PyTest, like derivative software from PyTest on mainframe. So the thing that you built for mainframe, does it have any application to any other system, or is this like very specific mainframe kind of testing?
Could you repeat this?
So maybe I will try to rephrase. So you have a framework which is suitable for mainframe, right? Does this framework, would this framework work on any other system, like a more like a common environment, not in a mainframe system?
Can you help me with that?
Hello, my name is Vladimir Filipov. I will try to answer to this question. PyTest is a universal testing system. We can use it for testing on every platforms, not every, including my mobile platforms, but in all desktop platforms. So, like PyTest, we can make tests for everything in desktop. But the TAP system which was demonstrated here is a system which allows to make easy interaction with mainframes. It allows to make complex tasks by simple commands. So this is a complex by PyTest and TAP system which allow to make, give to us simple interfaces for testing.
So basically, you're building interfaces for PyTest, right? So interact with mainframe.
Yes.
Oh.
So we running all tests using PyTest, but we import our TAP system which allow to make interaction to mainframes. Some other questions?
I have one. You showed that you're using XPath, but like why XPath, not like tracers, CSS selectors or something, as XPath are like quite fragile, right?
Yes, XPath is complex system for navigation in code, HTML code, but this is most powerful system. Usually we can use any other type of identification by ID, by CSS, but XPath is a base of the TAP system, so usually we are working with XPath.
Like, I guess basically what you're doing in Rocket's here software, you're doing the writing tests for the mainframe, right? Do you write also code for mainframe itself, or it's done somewhere else, or it's like with IBM working there by mainframes, or?
If we talk about Python, the main part of our work is writing tests on Python. For the development on mainframe, usually Metal C language is using. But if you want to know about Python on mainframe, IBM was ported the latest versions of Python to mainframe, so Python is available on mainframe, and a lot of modules are ported to.
Can I also add a little bit? So if the question was like if we write software for mainframe, so yes, basically the software which guys showed is also like part of our team's job. Just like this particular team is focusing on the test automation for mainframes, and the other teams are writing the code itself, what they would do.
I asked that because I was thinking like XPath, yeah, it's complex stuff to do and it's quite fragile, but I was wondering why like you're not using tracers for the code itself in HTML or somewhere else, because I have experience like XPath are horrible. But the tracers, for example, currently we are doing the tracers where you can write for, you don't need those complex XPath and etc. and you can just pinpoint what you need and you just quickly get it. I was thinking more, wanted to ask this way, because to learn, do you write the code itself for those softwares or you just get it and test it? So if you have control, maybe you can I just wanted to know.
Yes, in some cases it is better to include to HTML code some special IDs for testing and use these IDs instead of creating very complex XPaths which use a lot of levels on hierarchy.
Yeah. And one more question. I saw the first slide with the code. Is it the code that you write daily, that big?
This very big test, I think this is not
saw
a very
that.
good example.
Yeah.
It is better to divide it to many levels, to use fixtures from
It just
PyTest.
was one example. Of course, we can write better, and we have better, but this was just for explanation reason, just having line by line everything, you know. For the
Because I saw it like,
Yeah.
really? You're writing that?
It should be divided.
Okay.
Any other questions?
I have one.
Okay.
So I am not familiar with Mainframe, haven't worked with it, and I guess most of the online viewers as well. So is there any way how to like learn all this kind of stuff, not like by joining a mainframe company? So like that, having a mainframe at home, having an environment at home, right? Some kind of
Maybe that is like
Just
like a
for-
Docker or something that you could use in simulating it. Yeah, interesting.
Yeah. In internet I see some instructions how to make our mainframe emulator at home. I think it can be executed even on Raspberry Pi, but I think we have enough mainframes at work, so we don't need to do it at home.
Yeah, well, there is a mainframe. You can install it called Hercules. It's gonna run a lot older ZOS. Well, ZOS is operating system, runs on American hardware. The Hercules is older version of it, but if you need to know how to basically system reboots, installs, and stuff like that works, you can do it. I'm not sure about Dockerized version of it, but the simple regular style, yes, it's available. You can find it, you just Google it.
And mainframes are like what? C language? What else?
Metal C.
Mostly, right?
Yeah.
Also assembler. Or both
Yeah,
live stream.
I understand that it's like by de facto. But
Yeah, but for the workload, you can run any type of workload. You can run Java, Python, C, C++, and stuff like that. So, regular web server, like Apache, Tomcat, you can run. More sophisticated WebSphere API. And so, lots of stuff.
So my final question, so let's say you have like 5 years of programming experience, how long it would take to switch from, let's say, standard programming to like mainframe programming? Let's see. What's your opinion on that? Because, well, it seems it's hard to switch into mainframe as this.
If talk about testing using Python, this is very similar because my previous experience is testing using Selenium, testing for web interfaces. If to compare to testing on mainframes, we have a very similar library which allow to locate some texts, fields on mainframe applications, and simple enter some text to needed fields. So this framework have other methods, but this is very similar methods. If to talk about tab, which writing in Java, this more complex thing because we haven't very good framework which allow to interact with Java application, but this is similar to.
So Python for mainframe is only for testing and nothing else?
No, Python can be used and really used by IBM customers, for example, for data analysis. Maybe you know about Jupyter notebook. This is the system which allow to interact with data, and some IBM customers using Jupyter notebook to analyze data online.
On mainframes.
So basically they connect
Exactly.
straight to the mainframe and just use Jupyter to...
Yes.
Okay.
Thank you.
So this is a really final question.
Let's see.
Okay, thank you.
Thank you, John. Thanks a lot.
Thank you very much.
Mateus, also some gifts, some stickers. Okay, thanks a lot, guys.
So let's maybe make now a short pause, couple of minutes, and then we will switch to the other presentation by Petras. A short pause, have some snacks, some drinks. Thank you. Okay, so welcome back. So now we will have second topic by Petras Danavičius, Intro to Wave Function Collapse. And for our online viewers, if you have any questions or comments, please post it on the stream, so we will have opportunity to ask Petras later on. So Petras, over to you.
Okay, hello, my name is Petras Danavičius, and today I'm gonna talk about wave function collapse. So let's begin. What is it? What is wave function collapse? It's an algorithm defined or created by Maxim Grumin, and this is the definition of it. I'm not gonna read it because it's boring and it's too much text. What the fuck? We are TikTok people, we are Instagram people, we are not reading stuff. So what is wave function collapse? It is procedural generation algorithm. It's a more computer graphic or game dev related algorithm. Plus there is a wave function collapse in physics. It has nothing to do with it. It's different. So let's see some demo how it works. It generates interesting pictures out of other pictures, right? So for example, this one. Let's move on. There's another demo of generator. Okay, so it generated a castle, generated a lot of grass, and small castle generated a wall or castle with a lot of flags. So this is the capabilities of that wave function collapse. And okay, let's read some text. There is my small definition of wave function collapse algorithm. So you start it with a grid of tiles. Tiles can be, a grid can be 2-dimensional, 3-dimensional, 4-dimensional, and so on. It of course can be 1-dimensional, but I don't know why would you need it. So in my example, it is 2 dimensions. It's much more easier to understand and to visualize. So at the beginning of an algorithm, each tile starts its life with some number of states. In my examples, it's image fragments. So these are like 16 fragments. And each tile, so tile is this, can hold a state or can become one of the image fragments. So you can say that tile starts its life in a superposition of every possible state. And each tile can be collapsed into one particular state. Also, states or image fragments in my examples are limited by constraints in relation with other states. So, for example, a fragment with a right blue edge cannot stand near another tile with a red edge because the colors are incompatible. So how the calculation or collapsing works? You need to pick random tile with more than one possible state, and then select a random available state, meaning collapse it into that state, and then recursively mark all the neighboring tiles according to constraints. I will explain that part more in the next slides. And then you repeat this loop until all tiles are collapsed or there is no available state to collapse into. So let's start with the simplest grid possible. it's one-on-one grid, so there is one row and one column. And this tile can have all these positions, all these states. So let's generate, okay. It's very simple, we just pick one state and it works. It's very easy when your grid is very small and there is no. So let's expand it a little bit though, like 3 columns and 3 rows. So let's say I pick any state and all these other states are not compatible with this one. So as a top one, I can only select this one. All other states are not available, and so on. So what it does, it goes to each direction and marks the states or fragments as not available if they are not compatible, right? If I go to the bigger one, it goes through all the grid and marks all others as not available, right? So what we're gonna do, we're gonna do some live programming, because why not? And I will try to implement the whole algorithm live. So we need to implement solve function, and it has some parameters. And also some constants. So I'm gonna try to explain what it is. So num calls is a number of columns. Num rows is a number of rows, obviously. Num of fragments is a number of fragments, meaning 16 in our case, because there's like 16 items. And the function needs to yield or generate list or iterable of 3 of tuples containing 3 items. So first item is X, second item is Y coordination, and the last item is a number or index of fragment. So let's run it. So this is the grid containing only one tile, so there's only these coordination exists. What if I pick different one? Okay, we can pick last one. So last one is going to be 15. It's going to pick that. The only interesting variable is compatibilities. I will try to explain it. So it is a list, but it's 2-dimensional matrix encoded into list of how each fragment is compatible with each other fragment. So for example, I will select first one. Okay, let's select first one and run. So first one is compatible to itself by number of 3. It's a bitwise flag, so the directions are encoded here. So this tile can stand to itself from top to bottom and from bottom to top, because otherwise the colors are incompatible. If I try to put it near itself to the right direction, this is brown and this is blue, and it's not going to work. So let's move on. Now it's more serious. We have a grid with 5 columns and 3 rows, and we need to implement this algorithm. So let's start with a very stupid version of it. So it's going to be in num rows and in range num calls, and we're gonna yield just first number. Okay. I have also implemented error detection, so if it's not compatible, it's gonna mark it as this annoying color. So we are generating something, but it's obviously not what we want. So let's use some random int from 0 to num fragments -1. Why -1? Because round id is inclusive. It's a last index. So now it just picks random fragment and puts it. Obviously not what we want, but we have something to begin with. So the algorithm definition of solving this problem talks about states and its availability. So let's create two dictionaries to hold state. First one is gonna be selections. We're gonna hold if item is selected or not, and the second one is gonna be availabilities. It's gonna be also a dictionary, and let's fill them with selections. No, nothing is selected at the beginning, and everything is available at the beginning. So this number of fragments items, so let's just multiply it. And we have our initial state. Now we need to start a loop and pick random items. So let's start a loop. Actually, I don't like to start with while loop, while true, because it can hang if I will make some mistake, and I will make some mistake. So I will start with pseudo-infinitive loop, and then pick unselected. Let's implement pick unselected as return none. So if nothing exists anymore, it means we need to quit generating. Okay, let's actually implement it in a very naive form. So if selection, okay, so selection is coordinations plus is select. If item is not selected, we can return. Okay, it should work. So now what can we do? We have a coordinations. Let's have index of the fragment, again as 0, and yield it. Oh, I cannot type. Index. And let's mark it as selected. X, Y, true. Okay, something is wrong. It in selections. I cannot type. And I don't know Python. It's always returns 0. Let's print, let's reduce the number to 1, and let's print
Line 30. It's if not clause.
line 30. Oh, okay. Pair programming works. I need to increase this. Boom. Thank you. So we have wrongly working something, but it generates. It's nice start. Let's move on. We need to pick an index as well. So pick available fragment. We're gonna pass coordinations. Style availabilities. We need to. We're gonna use same naive implementation as pick and selected tile. So it's gonna be for cycle. It's gonna be index and is available in enumerate if is available, then we're gonna return either x, else let's return none. So we need same break here. If index is none, that's great. Same thing is gonna happen again because we haven't actually done anything with availabilities. So first thing we can do with availabilities is mark them as not available when the item is selected. But it's not true because one item is actually available is the item we just selected. So let's mark it as true. And now we need to implement a recursive part. When we select something, we need to mark these as unavailable, and these as unavailable, and these, and then starting from this tile, move to all its neighbors and mark them as well. So let's call it with date. I'm gonna pass these other params. Let's define all the neighbors. I'm gonna define them as a list of tuples of 3 items. I'm actually gonna start using bit flags, directional flags. As a last item, so it's going to be all 4 directions. And then I'm going to need new coordination. Let's name them, oh no. Let's name these parameters as x1, y1, because it's going to be beginning of our journey, and x1 gonna be our destination. Okay, so from top to bottom, so if I'm moving from here to bottom, it means I need, so rows I index at like 0, 1, 2, so if I'm moving from top to bottom, it means I actually need to add one. If I'm moving from bottom to top, I need to minus one. If I'm moving, and columns are indexed in natural order, so 0, 1, 2, 3. So from right to left, it's minus one, and from left to right, plus one. So let's, for each our neighbors, and it's going to be direction in neighbors. I need safety check because if I move from this corner item to the left, there's nothing here, so I don't need to do anything. I'm gonna reuse my selection dictionary to do that. Selections. If it's actually not in selections, not break, continue. Now I will need to actually update availabilities. X1, X1 here, X1 and direction. But this, and also since it's a recursion, I need to call a recursive function to itself. There's a problem because let's say I'm in at this point, then I'm gonna go to this point, gonna go to this point, go to this point and back at it, and we have a loop, infinitive loop. We need, each recursive algorithm should have a stopping event, or like, so we need it as well. What's it gonna be? So let's say I'm moving from this to left. There's nothing to collapse and there's nothing to mark as unavailable because it's already selected. Or let's say I'm moving from this to this, I'm updating and then moving again, and I'm trying to update, there's nothing to update, I've already done that. So update availabilities should return number of updated availabilities, and then I can just add a if statement, and I'm gonna go deeper only if I've done something useful. So def, okay, let's copy paste everything instead of writing. Let's start by defining two lists of indexes. First is going to be for starting position. So how we named availability, okay? Availabilities x0 x0. We're gonna select index for index is available in if is available. I think so. Oh no, I probably need enumerate. Then we're gonna select, we're gonna copy paste because why not? Gonna be 1, I'm gonna change. We're gonna mark the ending. We're traveling from this to this tile, so we're gonna mark availabilities of these tiles. So our loop needs to start from ending, not from beginning. Let's compatible is false until, so fragment is compatible only if we find some compatible tile in our previous destination. So index 0 in fragment 0. If comp, we're gonna bring our direction, we're gonna check binary, and if it's more than 0, it means it is compatible. Compatible equals true, and we can break this. And if not is compatible, then we need to actually update our availabilities as false. Equals false. And since I said that it's gonna return number of updated, we need to actually record the fact that we have updated num updated. It's not gonna work, but let's see. Yes, comp is not defined. Oh, so we actually need to take a value out of this list. We have 2 indexes, so let's define the index 0 num fragments plus index 1. So com gonna be com index. Okay, it works and there is no errors. Let's run it again. There is a bug in my software. The problem is it works, but it only generates same picture. Why there is no random call in my code? And since it's pair programming in our code. So let's add some randomness. So instead of just returning coordinations, let's have a list and let's append them. So we only return none if there is nothing in the list. Otherwise, it's gonna be unselect. Let's see. Okay, it also generated a Ukrainian flag, which is very nice. But it never picks up any graphs. Why? Because we also need to randomize our fragments, picking available fragment function as well. Let's use same technique. So it's gonna be indexes and instead of returning, let's add so if not indexes otherwise we can call random choice. Let's run it now. We can see some graphs. So I think that's it. It actually works. It actually generates different stuff. So this is wave function collapse in less than 100 lines of code. Let's see if let's copy paste it. We have much denser task for us, and let's see if our code works. Oh, there's one to do. I can actually uncomment and run. Okay, it seems it's working and it makes sense. There's no errors. It actually works. Let's see it again. Everything, it's fine. Yay. So thank you. If there is any question, I would gladly answer. I would imagine that, okay.
So you're an expert in this algorithm. Are there any like real life applications of this? Like you mentioned gaming, but how does it present itself in the gaming industry?
So in gaming industry, there is actually, especially in India's games, and in India game, nobody likes to create levels. Everybody likes to auto-generate some random levels, like rogue-like games. So they need something to generate randomness. And let's go back. It's very useful. For example, let's go. Okay, this slide is interesting. So let's say I need some randomness. I click, I got some randomness. Let's say these are tunnels I can travel with my hero. But I can hand pick something. Let's say there's going to be big bosses over there and over there, and generate again. So I can, there's symbiosis between like hand picking and random generation. Plus, the pure randomness would generate very nonsensical images. This algo actually checks for compatibility, so you can make sure that everything makes sense.
So aside from gaming, is there any other like
I don't know.
industry?
Probably not. I'm playing with the idea, if you work on, let's say, on some usual web application, and you have a lot of customers and there's a lot of data, and you want in your dev machine to test something that's failed in production, but you're actually not allowed to access customer data because of GDPR or, let's say, HIPAA compliance. So what you want to generate some really big but natural looking data set to check some performance issues or so on. Maybe that can be used. But generating visual stuff is more game dev-like, so I don't think a lot of other. Oh, if you want to get rich, probably generating some NFTs.
3D, we go.
3D.
I know that it's random, but is it possible to predict that, or let's say not predict, but expect something specific in that case?
You can. For example, it's very small picture, so I'm sorry, but if you notice, there's a lot of empty fragments. Mm-hmm. So that's why there's quite a lot of white space everywhere. It actually failed because there's no possible state. or by, if let's say I would add a Python logo everywhere, there's going to be much more Python logo generated. So you can affect that
so by the image you can affect the outcome, what will happen.
Because it's going to pick randomly. If there's more available, it's going to pick more.
Okay.
So there's several ways. One is like hand picking. The other one is like preparing your data set to introduce some kind of skewing towards some wanted result.
So the same could be used for, as you said, for testing, right? For generating, you could like add specific data to predict it, to make sure that it will happen.
Yeah. Or on game dev, let's say you want a level where boss exists, and there must be one boss and random tunnels to go to the boss, so you can do that.
So actually there is much more effort in having all those constraints in that matrix.
Yeah,
lots of manual work.
The application, the doing visual representation of algorithm is much more harder than algorithm itself. As you have noticed, it's quite simple. It's just...
So the images are the hardest part.
Yeah, and painting, drawing is also annoying. For example, these it's labor.
A little bit off topic. What kind of tool are you using in your presentation?
I can actually close this. It is a Godot game engine. So I can actually... So there's... Right. So it is this place. Some code.
Custom made.
So the whole presentation is in the game engine itself.
Yeah, it's coded in game engine. It's a Godot script, not Python, and there's some C code to like connect Godot engine to Python interpreter itself.
Like Inception. Game within a game.
Okay, presentation. So I think that's it. Thank you all very much. Oh, one more thing. Go check out PyCon.lt. There's going to be Python conference late May. So go check out. It's going to be really good.
Yeah, I saw that one, but it's like 2 days conference, or it's like workshop and conference?
2 days conference.
Conference?
Yeah.
2 days, yeah.
Speakers are invited. So thanks a lot, Petros, for your presentation. It was a pleasure to have you here. A small gift from this meetup organizers.
Thank you.
Thank you. Thank you everyone for watching.